12. Okay, so we are going to be looking at exponential equations for the next few weeks. And when we have exponential equations, there's a lot of real-world applications to these exponential equations. That's one of the reasons I like this unit. An exponential equation looks like this. This is the basic form of an exponential equation. Where's the x? The x is the exponent. Everything with an exponent is not an exponential equation. Y equals 5x squared has an exponent, but it's not an exponential equation. By the way, do you know what kind of equation that one's called? This one is called a quadratic because x is squared. It's not exponential. For it to be exponential, the variable has to be the exponent. And that's what causes something to go viral, is because this exponent is changing, making it go, the numbers get very, very large. Also, as in my first example, the numbers don't always get larger. Sometimes they can get smaller. The other day, I was unfortunately sick, and so I took some medicine, and so the medicine killed the bacteria, and it killed it in an exponential manner, but it was killing the bacteria. They were going away. And so exponential equations can get bigger or they can get smaller. Okay, so here I have an exponential equation in my calculator. See if you can guess what I put in my y equals to get this equation. Anything that has the form y equals ab raised to the x power is an exponential equation. A is the initial amount that you start with. B is your multiplier. If your b is greater than 1, your equation is going to be growing. It's going to be going viral. If your b is less than 1, it has to be positive. If your b is less than 1, it's going to be decaying. What's another word for decaying? Dying, decreasing, and it's going to be going down. So even though we call it a growth rate, the rate is making it go down. I think in some of the, this assignment it's called a decay rate. It's making it go down. It is exponential because x, the variable, is the exponent. A is the initial amount, b is your base, your multiplier, and then x is your exponent. Okay, so in example number 1, we have a 2 out in front, the 1.25 raised to the third power. This is what you look at to answer the first part. Is it going to grow or decay? If this is more than 1, it's going to grow. What's the initial value? What's the number out in front? The a in the equation is the initial value. The b is 1.25. That's the base number. The rate is a decimal number. Now, we always are comparing to one whole 100%. We're always comparing either it's getting more than 1 or it's getting less than 1 or 100%. So to find the rate, it's b subtract 1. It is 1.25 subtract 1. How much is that? The rate is a decimal number. To change a decimal to a percent, you multiply times 100. because the word percent means part out of 100. Now, is that all pretty easy? See, I told you this was going to be easier. Now, want to see, okay. To determine if it's oh, wait, I go back to that one. There's a thing I needed to say here back on this one about order of operation. Some people want to multiply the 2 times the 1.25. Try to simplify it. That is, you cannot multiply this number out in front by this base number because order of operation says exponents come before multiplying. You would have to raise it to the 3rd power before multiplying by 2. You cannot multiply the A and the B together because the B has an exponent. An order of operation says you can't multiply before exponents. Okay, now back on problem number 2. Growth or decay. How do you know it's decay? Less than 1. The initial value is the number out in front of the multiplier. Do I have a number out in front of the multiplier? Then the initial value is 1. I could put a 1 out in front without changing the value. Could I put a 0 out in front? If I put a 0 out in front, the whole thing would 0 out. And so the B here is 0.25. The rate is not 0.25. We're always comparing to 1. And so what did I do on the previous problem to find the rate? B minus 1. And B is 0.25 minus 1. What's that? Yeah, but I can't have negative. So in order to fix that, I just take the absolute value of it. Remember absolute value? What's the absolute value going to do to my negative 0.75? This rate always has to be a positive number, and so 0.75 times 100 will be 75% decrease. And a lot of times, very, very often, we talk about these kinds of things in terms of percents. Is why we're putting this on our notes. Okay. You figure out 3, 4, and 5. Okay, let's look at your answers. Problem number 3. Why is it growth? This is larger than 1. Why is this 1? If there's not a number out in front, it's 1. This is just the same as that. You take off the 1, you multiply it by 100. Everybody got that one? Any questions? Pretty easy. Okay, did we get this one? Why is this one a decay? Smaller. There's no number out in front, so the initial value is 1. B is this number right here. The rate, where did I get this 57 from? 0.57, I should say. 0.43, subtract 1, but it can't be negative, so you just take the absolute value. By the way, these, when it's decay, these two numbers have to add up to equal 1 whole or 100%. And to change it to a percent, you multiply by 100, because the word percent means part out of 100. Did we get the growth? The initial value is 8. The B is 2.59. But this is not 0.59. This is 2.59 subtract 1. So what would that be? 1.59. You get that one right? Because that one sometimes tricks people. Times 100 makes 159%. Next, this one is a decay. The number out in front is 2. This is 0.61 for the B. Where did that number come from? 0.61 subtract 1, but that's a negative number, so we just take the absolute value of that, 0.39. These two numbers on a decay will add up to equal 1 whole. And that is 39%. So, let's see how to apply this to a real world type problem. Because this kind of problem is something a biologist might figure out about populations. Now, the first thing we need to know, is this a decay problem or a growth problem? What word tells me whether it's decay or growth? So increase is telling me what? It's growing. And do we know how to write 2% as a decimal? Because when it goes into my equation, it's going to have to be, it can't be in percent form. So how do you write 2% as a decimal? So the rate is going to be 0.02. If you multiply by 100 to go from here to here, to start with the percent and go backwards, you divide by 100 because percent means part out of 100. So the growth factor, what's a growth factor? It says right here on the front of your paper, B is the growth factor. And to find the growth factor, it's 1 plus the rate if it's a growth factor. So this is 1 plus 0.02. Do we already know what rate of function means? What's another way to say that? Sometimes it says write a function model. This says write a function to model. That means write the equation. So this is the equation that we're writing. What does the A stand for? The initial value. How many people did we start with? Now, we can write 6 with all those zeros, or we can just write the 6. What's the B? 1.02 raised to the x, and then we are put out to the side. This is representing billions of people. So, what is the estimated population at the end of 2018? So, to figure that out, we take this equation, 6, 1.02. This started out in 2000, and it's asking me about 2018. So how many years is that? 18 years. So we would raise this to the 18th power. And that's what you would put in your calculator, 6 times 1.02 raised to the 18th power. You better sit up. So, what number is that? Y equals 8.569 would round to 57. Now, is that 8.57 people? Population, is that 8.57 people? 8.57 billions of people, because our equation was in terms of billions. The first thing we're looking for is a word that's going to give us a clue. Is this going up or is this going down? Do we see a word that's going to help us figure that out? I'm not sure if you're familiar with this word. This is a banking word. Depreciate means that something is going down in value. When you buy a brand new car, does it go up in value or does it go down in value? And so that depreciates. However, if you bought a classic car, you know what classic car is? Not necessarily just old, but old and valuable. Because I have some old cars, but they're not valuable. And so certain models of cars, my husband likes the old Mustang. Certain model years of old Mustangs are valuable cars, and they appreciate, not that we appreciate how good they look. Appreciate is a banking term, meaning goes up in value. Depreciates means it's going down in value. How do we write this number as a decimal? Divide it by 100, because percent means part out of 100. Since it is going down in value, the B is equal to 1 minus 0.143. So what is 1 minus 0.143? Now, that's not the equation. That's just the B. The equation is going to be like this. And so Y equals A. What's the A stand for? How much was the initial value of this computer? 6500. And we just figured out the B. Oops, left out a number. Raised to the X power. The X represents the number of years. And so, to figure out part B, Y equals 6500.857 raised to the third power. So, 6500 times 0.857 raised to the third power. Now, how did I know where to round this off? It didn't say anything about where to round this off. But what is this? It says money. And money has 2 decimal places. And so after 3 years, that computer would be worth just a little bit more than $4,000. Probably, depending on what the computer is, it might depreciate in reality even more than that.